Hello, Cardstack community. This is Chris C., the founding director of the Cardstack project, talking to you today about the architecture behind blockchain registries. That's something we've been thinking a lot about, especially as it relates to building registry that's scalable, that takes advantage of the blockchain's trustlessness, but also solving problems around multi-party interaction, scalability, the ability for people to own their own data, private and public. So today we're going to focus on looking at a couple of architectures that has been kind of come out recently, especially last week. Last week was New York Blockchain Week, so a lot of people came to New York, and some of them I visited in different events around the city, but some of them came over here. It was a pretty busy time. As you can see, our studio here is reconfigured, as we've talked about, and it was pretty busy last week. So we have, in the Blockchain Week, hosted a Layer 2 workshop that was, so Layer 2 was the hashtag and the main focus here, hosting people from different projects, Solar Network, L4, and other type of a state channel approach. Now obviously the different Layer 2 technology from payment channel like Lightning, and then on the Ethereum side there's state channels, and then also Plasma, which is kind of a side chain instead of state channel, and they're kind of composable. So it's great to be able to have people here, the user office, to kind of try to find a way to converge towards a state channels API that can be in common for people using MetaMask, or even for non-plugin based interactions. But it was also really interesting to have catch up with old friends to kind of understand what they're trying to solve, and kind of what Layer 2 can bring with a certain type of application the state channel is appropriate for, Plasma chain is appropriate for, and obviously payment channels like Lightning and stuff like that. Now, when it comes to building registries, things that are for lookup, for people to publish it, so they say, hey, these are all the information about me, whether that's identity, or in a particular area we're working on content and rights and metadata, the things that Cardstack is focused on. We have a slightly different approach, but it was really great to see last week that the Decentralized Identity Foundation, and more importantly, the Microsoft being a main sponsor of this, announced the Identity Overlay Network, which is ION. So this is a side tree base, so this is a little tree icon on the side you see here, to be able to use the Bitcoin blockchain. A little bit of a surprise. It is chain agnostic, so there's a version from Transmute that's working on a Ethereum version, but that's showing that this idea of side tree can allow you to anchor certain information on a blockchain and then use a content addressable storage system like IPFS to make it all work. This was a thing that's been pushed very hard within Microsoft by Daniel Buckner, which, by the way, it was actually interesting. I was going back to some of my notes on, like, where the origin of these concepts of Layer 2s and different area. And one of the most kind of a watershed event, not necessarily because of what the output of the event was, but also it was the people participated, is that in 2016, the W3C hosted a workshop in distributed ledger on the web. So this was when W3C is looking at whether the web standards and the idea of blockchain can come together. And it was held at MIT Media Lab in Cambridge, Massachusetts, and I was on the program committee. And I was like, hey, that's cool, because Daniel Buckner and myself were part of this relatively small group of people that led by Doug Chappell at the time, who was a part of the CSS standard, trying to see if there's a role that W3C would play. I was at the time working on a project called Monograph, and Monograph was a W3C member, so I was on advisory council. It was a good opportunity to see if there's a real match. But just look at this list of names, right? Juan Benet from IPFS, Christopher Allen for Blockchain was instrumental and funded a lot of the aspects. You see the Blockstack people, Ryan Shea and Munib was there as well. And then, Consensus with Martin. So Trent and Bitcoin ChainDB, and now Ocean Protocol. So this is a who's who of and Rick Dudley from Eris, and now a real thought leader on how to do these kind of things. But it was really great to see that what we kind of come up with, in this exchange of idea, the workshop, turns out to be different approach, including this idea of the overlay network. For those that's kept kind of in touch with Cardstack and what we've been working on, you will see that this whole Bitcoin and IPFS thing seems awfully familiar. It's because that the Bitcoin part is a distributed ledger, and then the IPFS part is a type of distributed storage. and you have to orchestrate the reading and writing and polling using the ledger to get you the information, and then getting the information from the storage and then unwrapping it, creating a cache so you can tell people, hey, this is my identity, this is my certificate, this is my driver license information, or my university degree information. This seems awfully familiar. It's because a couple of weeks ago we talked about Gitchain, which is kind of cut from the same tree, like side tree, it's cut from the same tree, where instead of using this specific side tree structure, we just say, you know what is a tree, but a Git repository like a folder structure has it. And this idea of using this pack file, which is the changes that they made recently, and then creating a reference or ledger, and then publishing that ledger, and pulling back down from the ledger this reference, and then unpacking the pack file to make essentially a copy of any type of content, data, and code. This idea of using a tiny bits of on-chain data, in our implementation we use Hyperledger Sort 2 for permissionless blockchain. We're working on Ethereum version of it, and then the pack file, which is any arbitrary amount of data. We've used S3 like a regular cloud storage, but we're also working on an IPFS version and pinning certain types of data into an IPFS node. So this is what we're working on with Gitchain. This is extremely similar than the specific identity foundation version of this Ion network, where the pack file is basically this batch file they're calling, which is these deltas of operation you've done, and the reference is what is being pointed to by, in this case, a Bitcoin blockchain. It is actually fantastic to see that this idea of a reference is small enough that you can go and put it into Bitcoin. Monograph, which is a project I worked on in 2016, in that time, was storing some pointer information on Bitcoin, which is not a lot, right? Op return, which is the basic standard that's being used there, is not many bytes. But if you have enough information and you can shrink your anchor information small enough to the side tree, then the anchor file can provide additional pointer. Now, obviously, Ethereum network is a little bit more storage, and you can pay for it by paying gas. That's why I think this infrastructure for both the Ion implementation, as well as the more general version of Gitchain, which can be used for more than just identity. You can use for content sharing, data sharing, and we'll talk a little bit more about what type of infrastructure we can build with that. That's actually really good that we're converging towards this type of layer 2 architecture, not just for micropayments, which is what the state channel, or the type of blockchain on top of blockchain, which is what the sidechain or plasma chain, or in some cases the Polkadot type of approach is doing. So this is a unique approach, very grateful and glad to see other similar approach. And by the way, Cardstack Hub as an infrastructure can support other type of encoding, including the one that the Decentralized Identity Foundation is putting forth via the W3C community group. This is interesting, and we're kind of looking at how much of our on this structure is compatible with this update payload idea. And I think our thinking is that we can probably support this and allow a Cardstack identity to be based on the same standard. It using Cardstack as an implementation, which gives you a little bit more flexibility to put more things on this kind of anchored chain, make a chain approach. So a great week. Some people has been asking me, especially during the blockchain week conversation and dinners, Cardstack sounds like Blockstack. How does Cardstack support the Blockstack? Well, the truth is that Ion compared to Blockstack is also kind of interesting, which is Ion has this kind of structured data and saving data and Git-like commits, which is how Cardstack works. And whereas Blockstack is a little bit more general in terms of the data storage structure, and that's based on this OSS community concept called identity hubs. So there's a lot of correlation between that. Now, our commitment of using Git really allow it to really anchor much more accurately than if you just have pointers. And if you want to look at my talk about 2 weeks ago, I talked a little bit more differences between a more generic IPFS Ethereum approach versus using Git as an anchor. But they're all converging within the same thing, and it is really a matter of what the runtime is. Does it require a plugin? Has to be a desktop app? Can it be on the regular web? And these are the ideas that I think is much closer to what Daniel is working on, which is allowing regular website to move away from Google login, Facebook login, and using this decentralized login. We'd love to support that when that comes along. And if you want to learn a little bit more about what Daniel was talking about, there's this great podcast which was published a couple of days ago, which is this is a link right here, and I'll put a link on the YouTube when that happens. It's a little bit long, but it's actually a fantastic overview of what's going on. So that's kind of the state of decentralized identity on top of a layer 2, registry infrastructure and this kind of identity registry. But today I want to talk a little bit about a project we've been working on for a little while conceptually, but from a programming and using Cardstack Hub and Cardstack infrastructure to deploy and build a real working application, which is something we've done in the last 6 months or so to not only produce a proof of concept, but also to validate a lot of the ideas about how this Gitchain things work. So in 2016, this is about the same year that W3C workshop happened. I got involved in this music project. I'm a musician by training before I became a computer science engineering person. When I heard that dotBC want to work on an open source, globally accessible, decentralized, and interoperable registry of music rights and rules around a format for music called dotBC, I was like, well, sign me up. Like, how can I help? And for a good part of its history was just kind of figure out what the architecture would be, how this nascent technology, which whether it's Bitcoin at the time we were looking at, and then Ethereum growing up around the same time as the dotBC was done, it was really interesting to me. What's interesting about this, and most people thinking about dotBC, is like, why is it called dotBC? Because dotBC was initially conceived of, at least, as a blockchain anchor replacement for .mp3. So for those who still remember .mp3, so before the Spotify era, when you have to organize the MP3 connection in Winamp or later on in iTunes, you can go and to get info on a song and like update the name of the song. Maybe it was misspelled when you downloaded it or whatever it might be. Hopefully you paid for it. But when you can change it, that metadata about the song name and who wrote it, who's the composer, what year was copyright, it's totally up to you to change. So there's no global accessible, right? You can say, I own this song. I wrote this, Paul McCartney song. Nobody can change it. It's true on your iPod or on your iPhone. So this idea of metadata being inside a file was always been around. I mean, that's how you edit, your music collection on your music player. But this idea of having a blockchain anchored music format that if, let's say, the information changed or the ownership information about the particular song's changed or cover art has been updated, it can cascade to all the players. That's pretty interesting. So blockchain being the source of truth, but then it is still a physical format in your computer. So that was the basic idea of dotBC. It has evolved quite a bit in terms of whether it was a consumer format or it's really an enterprise solution and somewhere in between. So dotBC, if you think about it as a registry, if you look at it not in terms of the file format itself, but what is a music format or music registry needs to include. So let's go through some of the requirements, and these are requirements that was collected over the years and really guided our team and also like my personal thinking about how real-world blockchain application needs to behave. One is that there shouldn't be a central authority. So there shouldn't be a website you go to, whether it's .bc or Spotify or Google, whatever it may be, that determine what the data of a song or what the correct master version is. It should be a decentralized system. And the core data should be accessible by everybody. So there should be a portion of this registry, maybe not how much you got paid last year as royalty from a song that was popular in the 70s, but certainly the basic who owns it, maybe who played in it and who was a guest artist on that should be accessible by anybody anytime. Part of the truth of the web, almost like a Wikipedia page. But sensitive data should be kept private because, if you're negotiating percentages, that's sensitive. That should be none of the business, the general public, but knowing that two songwriters are finding an equitable cut or resolving a dispute is a really great thing to do in private. This idea of that all this data that exists on the blockchain can still be a file, like at the MP3, you just download it, you hex it, or even stream it to your computer. So this idea of the duality between the online registry, which can split data in different forms and put it on the blockchain and decentralized storage, can kind of get all download back together in this bundle, which is what we call dotBC is a very important requirement because creators, when I write a song, when I record a song, starts with that bundle, this zip file, this folder of the thing I'm working on in Ableton Live or Pro Tools or whatever, Logic or GarageBand. And then it's when I distributed it that it becomes this kind of cloud information. But be able to have that duality and go back and forth between the musician's view of the bundle versus the music industry version of the registry, and then the consumer, the person listening to it, also actually sees as a bundle of things that's related to the thing, almost like opening a jewel box in a CD. It needs to scale, and it's hard to take blockchain, especially even today, to have all the music catalog is 50 million plus, maybe growing rapidly every day, and then all the fields at least 100. That's a lot of transaction on blockchain. Even Ethereum blockchain is only about 300-400 million transaction. I'm already blown through that just by recording each field into the blockchain. So we have to really think about that. And then the history amendment, not only what the current version of it, but also history, not just history of spends and cryptocurrency exchange, but history of changes across multiple parties. Like, hey, I transferred this song to you because I sold your rights. That should actually show up so that we can pay the right person the royalty. But some of the changes can be proposed, but it could be approved or denied. Someone say, hey, I claim to own this Beyonce song. Well, you're nobody, you're just trying to steal someone's right. In a decentralized system, you have to decide that the community or that part of the song that decide that person trying to steal someone else, if they're not really a legitimate label or musician, how can you deny that? And that's relatively hard to do on the blockchain because, blockchain, everything is true, everything is a state machine, you move it forward, it's hard to dial it back. Approved change, only things that's been agreed upon can be official, the other one has been discarded. You can make a proposal that you think you own the song, maybe you did, and maybe it's a mistake that everybody's making, but it could be also be fraudulent, so dealing with that system. And then the idea here is that based on who is submitting it, is it coming from the label? It's coming from a label that has a history, like 15 years history in the business, or has been was the representative for Beyonce for this last contract period. That can be scored, so that we can look at the blockchain and provide some sort of trust score based on where it's coming from. Obviously, once you have that information, you can then filter and search your own songs that you have added to the registry, but also public information. Let's say you're making a cover song, you'll be able to search for the right song and say, hey, I'm covering that song, and be confident that that's the song that is the right one. Because God knows there's many versions of Somewhere Over the Rainbow. If you're making a cover song, you want to make sure you're tagging or associated with the right original recording so that the royalties for the musical rights of it is going to the right artist, right? It is the right estate. We want to be able to import and export existing catalog because most things are not on the blockchain, are not on registry, so they're in these kind of existing enterprise systems, so import export is important. As we're going to orchestrate information in and out of different systems, streaming services, submitting to supply chain, doing certain type of, whether it's watermarking or fraud detections or data cleanup, there's a lot of workflow that the registry should communicate with, not only centrally, but on the way to the registry, on the way out of it. So how do you create the workflow orchestration? If you're going to build a registry, there should be, especially an open source one, there should be a built-in interface that's user-friendly. You can customize it, you can use something else, but there should at least be one of those things. And then participant can run their own node. So if I say, I want to join the music industry registry, you should run your own node and then be a part, 1/15, 150 of the network, much like joining the Bitcoin network and be a miner, you join, or Ethereum network is a full node, we want to have that characteristics. So this all is sensible and it all makes a lot of sense. But it turns out this is kind of scary, right? So you probably want a blockchain if you want to have no central authority. Core data, you don't want actually people go to the Etherscan, you want to actually have a web page, like a CDN, a very fast loading web page. You probably want to have some sort of social network to determine, hey, are you a part of this song? Did I co-write the song with you? Are you the label? Are you the A&R rep for this artist? That requires some understanding of context and identity and relationship. Oh, that's kind of like a social network. And then if we want to do bundles, we have to deal with zip file and folder structure and unwrapping, unzipping, and stuff like that. And then if you want to scale to the music catalog, you probably need a regular database because blockchain doesn't really scale to how many transaction and splittering, mutation, and amendment that goes along. If you want to log the amendment, you need a ledger. A ledger is not necessarily a blockchain, but you can have a ledger that's not a blockchain, but it certainly have this idea of append-only tracking the amendment. But because changes can be approved, and now you need a workflow system. And because some of those changes may be fraudulent or someone proposing it and say, oh, don't worry about it, I just made a mistake, I thought this was a song, you need a version control system where you can discount a certain branch. Analytics, you need to do system. You need to have a search engine next to it. An ETL tool, extract, transform, and load. So these kind of bulk data tool that's very much part of big data or existing enterprise data center, you need to have that. In that workflow with third party means you need to have an API layer. You need to build a web app, logged in and secure, almost like a SaaS app. And then you need a cloud platform that this can easily run. So blockchain, web scale, and social network, zip file, database, ledger, workflow system, version control, analytic, search, and ETL, API layer, web app, and cloud platform as a prerequisite of building a decent media registry for recorded music and music videos and maybe other media assets in the future. Okay, that's a lot to deal with. And that's been something that we've been working on, at least personally. I've been trying to what kind of architecture can satisfy, if not all, a good part of these requirements so we can build a registry. But this requirement continues. If there is no central authority, you probably don't want a database. So this is like thinking about the anti-patterns of it. So you don't want a SaaS app to store your data, because if you store it all on a Salesforce.com per user, then how can public access it? And usually, SaaS products are not designed to scale to random people clicking on a link to get it. So you probably can't put it in a commercial application. It has to be really a public web infrastructure. So you can't put this on a public site, however, because that's sensitive data. So you have to have this, private versus public facade. And it's coming from many sources. The master file is coming from this service, the publishing data is coming from the publishing house, and the label has some information, and maybe statistics is coming from iTunes, right? So there's a lot of information that when you download a bundle, it's actually sucking all the information that exists and all around the world and all the different music company and music ecosystem, or maybe some that's not even music, like YouTube. How does that even work? So it's a lot of data source amendment. If you want to scale, not a blockchain. So how do you reconcile that? It can't just be a flat table, because you need to have history of amendments. So things have to be based on operations and delta, not just like a list. There's more than one version. You can't just use simple rollbacks. Blockchain doesn't really have rollbacks. They only have forks, so that's even worse. You can't do a lot of the scoring using query time, because that's pretty slow. You have to kind of accumulate the score over time using a technique called dynamic programming, so you remember the results as you propagate. That changes the complexity of how you do the scoring. You can't just do a predefined query. You have people filter, I want to look at all the songs I've submitted to this thing that has made this much money at this time and has some cover song that is not licensed. What are those? You should be able to do that in an ad hoc way. Not just an API, because you're going to have to do this bulk import of like 600,000 songs. So yeah, there has to be a bulk API. You can't use off-the-shelf software, because you need this workflow integration with third parties, so it needs to be an extensible UI framework. It's not just a backend, and you have to have the UI, and it's not just a website, because just having Spotify.com or Discord.com is not important. This has to be an infrastructure shared across all of them. So, requirements and anti-patterns. So, this is really tricky. So dotBC is all the things in the green and not all the things in the red. And some of them is blatantly contradictory. It's a blockchain that's not a blockchain. There's a database that's not a database. And that's what happens when you start looking at building useful application with blockchain infrastructure being the back end of it. So what do? Well, you do it one piece at a time. So what kind of blockchain can scale better? So let's use the permission ledger that can work and use it judiciously, spoiler, in a Gitchain kind of way. Okay, if you have this new data, publish the latest version into a web CDN so that people can access quickly, including watermarking or listening to a song, Shazamming it, and then seeing it right there on your phone, but that's all done through a regular CDN-backed web page. So you're just generating and publishing this in a flat way so that people can see it quickly. But that's part of it. You need to be able to do the request action. You need to have some way to understand who the parties are, who the authentication are, working on that stuff. You need to have a downloadable bundle. You need to use Postgres, which is what Cardstack uses underneath it, and we use that leverage. Gitchain as a ledger, using branching and merging in this first version, and using multi-git in the next version to do a workflow system. The workflow version control system is Git, so you can branch and you can create a new version, discard it if you don't like it. GitHub is how we demonstrate a lot of this stuff and to debug it. Machine learning has been integrated. We have computer properties in the Cardstack Hub, so you can have a formula field that can say this is this field plus that field divided by that field, get you a score. If this field exists as 1, if all three exists is a 6. And then PG search, the ability to use the Postgres database as the basic JSON storage to review this information. We have a custom JSON formatter that checks into Git, and once you check into Git, it becomes a real extract. Cardstack Hub generates JSON API. It's a schema-driven API server. We created a web app, which I'm going to give you a demo. Actually, Dimitri is going to walk you through a demo of what that looks like. That's a small part of the system, but it shows you the user part of what's underneath it. And then it's currently hosted on Amazon Web Service. It's part of the POC. All of this was done by Q1. It was a lot of work to think through not only the specific music registry version, but also the infrastructure necessary to support this. So that's something that really helps us, right? Taking these difficult requirements, looking at Cardstack as a framework and a runtime, and say, what are the pieces we need to do to make this all happen? So architecturally, the platform is at the bottom, the API is on the top, and then the horizontal axis here is this idea that this part, the data comes through, the ETL goes to a folder, goes to a database, and then it gets exported out as a zip file. And then the API layer, capture the data, update the database, that gets to the version control, it updates the ledger, which updates the blockchain, and it anchors and runs on the cloud platform. So that's kind of the two axes. So a slightly prettier way to look at that is to put it in a diagram that shows that the database really is sits in the middle, and the ETL provides the feed of all the music data and music information. And this could be right now music data, in the future it could be book data, it could be video data, and episodic series data. It doesn't really matter. It's just something that will go into a folder that describes that particular piece of content, data, or person. And then the search engine is where you can pull that information into a bundle and take that stuff and denormalize it. It's not the official version. When you download the zip file, it's a copy of it. But the database has to figure out what's the truth, and that's the version control. So the ledger anchors on the blockchain, and the workflow system and social network, which is in this particular version not the main emphasis, but it exists to support the API. And you have a web app, which is authenticated, and a web CDN. So the public people goes to the CDN, just see the web page, who wrote this song? And very fast. And then the web app is where you can modify and change the thing which get published back to the CDN. So this is kind of the concept map that we've been working towards. If you look at the architecture map, hopefully for those that's been paying attention to the Cardstack Hub, the Cardstack Hub is the database. It is a virtual database, so it doesn't actually, it has a database engine underneath it, and it do scoring and searching and deal with JSON model and going back and forth between Git plugins and stuff like that, and can export CSV. It has a schema and can hook into, it doesn't contain, but can hook into machine learning and can export views and stuff like that. But the virtual idea is that this database that's scalable, that can allow us to capture and manage this catalog, is Cardstack Hub. Now, the cool thing about Cardstack Hub is that because it's getting its data through Gitchain and the underlying blockchain, anybody can run a hub and just use the blockchain and the information pointed by Gitchain and recreate your own database or your own Cardstack Hub. And then you can serve your own clients using the API that you provide, and then an app that's special to you, or you can customize the standard app. In this case, the dotBC app could be open source, and you can use that as a starting point to build your own music catalog app or even consumer-facing music streaming services. So that's what we built. So let's take a look at the music registry demo. And this is not the world's most polished UI, but because we're really spending most of the time on understanding how that underlying registry infrastructure with all those requirements since 2016-19 will look like. But it is a real thing, and so I'm going to hand it over to Dimitri to walk you through it.
Hello. Today we're going to show you music metadata management project that we created for our partners, Blockchain Media. It demonstrates the use of Cardstack Framework for edges editing UI, and the prototype of what will later become Gitchain. So let me log into the system. Once I'm logged in, I'm able to see, I'm able to browse the catalog, and there is a search. We can search by group name, by performer, by song name, and by internal codes like ISRC, ISWC, UPC, and some other codes. So here you can see that I have a list of songs returned, and some of these songs have master, release, and works data. Some only have master and release, some only works data. Those are different bundles managed by different organizations, and we'll get into this later. But right now, let's get into the song. So, for example, if you want to see the information, For Samsung, we go inside and you can see when you just logged in as a regular user, you can see some of the information. You can see publicly available information. Here you see some of the fields are marked with lock icon. It means that this information is protected and it requires additional authorization. You can request access to get to this information, like artwork or ownership rights and splits. So let's do this. Let's request access to that information. You have to request access separately to works, master, and release information. So here you see the request has been submitted, request has been submitted, all requests have been submitted, and let's log out as Dave and go to the approvers. Each type of requests go to the organization that manages that particular part. So for example, master and release data is managed by label. When I'm logging as label, I can see in my inbox that there is a request from Dave requesting access to private data. I can approve that request. And likewise, publisher manages the works data. I approve Dave's request. Request has been approved. And right now, if I log in as Dave again, I will be able to see the private fields. We're looking at the 1 week by Bare Naked Ladies. You immediately see that you got access to the artwork, which is part of private information, and more fields, like you can now play, you get access to the audio files, you can play them right here in the browser. Here. You see the splits. Now let me show you how someone can request editing the data. So for example, you're looking at the information and you notice that the data is not correct or doesn't reflect the latest changes, so you want to request change in data. To do this, you click the pencil icon and you see this request to create a branch. What it means is that you are not editing the master data, the actual master data, but rather you are creating a local copy and you're doing all the edits in your local copy. So I want to edit, for example, parenthetical title, and I say 1 week extended edition, for example. So I save this. Once it says published, it means it's published to my local branch, to the local copy. But the data is not there yet in the public catalog, only in my copy. So in order to for this data to get into the public catalog, I need to send a merge request. And I'm sending a merge request. The maintainer of this particular part of the metadata will receive it. So for master recording details, it would be label. And let's see, so I sign in. Now when I sign in as label, first of all, let's take a look at the public data. So you see, the changes I requested are not there. This is the public catalog that everyone sees. Now I look in my inbox and there is a request from Dave to merge the branches. I can see what changes have been requested, and I see that Dave requested to amend the parenthetical title. So okay, let's grant him. Approved. And if I reload the page right now, you see that parenthetical title has been changed. And when I log in as Dave or as anyone else, now I go to that song and I see that my edits are available to everyone now. Likewise, you can change any kind of data displayed here. What else you can do? If you have access, you can export the bundle. So you can export the data, or the actual data that you are able to export depends on your permission rights. So for example, if you are a regular user without access to private data, you will only be able to create a bundle that contains publicly available data. But if you are a privileged user, you see it takes some time. It collects all the available data, including private data, and that also includes the audio files, master and watermarked. Okay, we just got this, and it also contains the artwork. And not only that, but also here it contains audio files, but it also contains the original DDEX file for that song that contains much more information that was available here. Works details and master recording and release details each have their codes, ISRC and ISWC, and you can match works to master by those codes. So many of the songs already come pre-matched, but you can still do the matching, or if you notice that it is wrong, you can request matching to another song. So let me just show you how this works. We make a request to RAI catalog, and it returns all the matches by that song. So if we are initiating from the works, it will look up by ISWC. If we are initiating from the master, it will look up by ISRC, and it returns everything that has been matched. So for example, it returned 25 records, but those records are not in our catalog. Those were different versions. In this case, they were performed by the same artist. They might be parts of different albums or releases in different countries. If there was an associated record, it would be listed here and we could select it and match. But what if there is a missing record that you have something in your catalog that is not returned by RAI? In that case, you can just enter the ISRC code here and it will be matched. We can even do this. So let's, for example, take some other song and associate it, for example, Bus Rider by Anya Marina. Let's take this ISRC and associate it to the incorrect ISWC. That is possible. So now if you make a search, you see another song has appeared here, and if we go here, you see that the master recording for this song is associated with the ISRC for incorrect song for 1 week. As you can see, we save the data, all the data in the GitHub. So we're using Git repositories as our data source. Every commit gets every commit gets synchronized to the blockchain. Actually, to synchronize every commit, it would be very expensive. So what we are doing here, we are doing bundles. Every time user sends a merge request and that merge request is approved, only then we create a bundle that gets recorded on the blockchain. So that way we record only milestones. And let me show you, we created the blockchain explorer where you can see those commits. So this is the state data pulled from the blockchain. So this is how push looks. And right now it shows it points to the end of chain. This is the latest commit. You can click on it and you see that commit in the GitHub. You can follow the chain back, so, and show previous record, previous, and so on. So if you need to create another node, you can point a new node to that to this blockchain. Right now we are using Hyperledger. So if you point it to Hyperledger and point it to the end of chain, we have a CLI that can restore the entire state of Git repository from the blockchain recordings. And that concludes the demo of dotBC music metadata management system. Thank you.
So that was a little glimpse of how the deliverables building on Cardstack Hub, live code deployed, has worked as a way to capture this limited sample catalog that's provided by Warner Music Group and Warner Chappell Music. They want a way to correlate the music thing, and this is a great sample set because it has all the challenge of a real data set, and it's fantastic to be able to use that as a way to learn what we want to do and how we can move forward to build this infrastructure. I think the one thing that became very clear looking at this architecture map again is that the workflow system needs some working, which is that right now the idea here is that you have a song and then you're kind of initiating action by saying this field is wrong. But the truth is that most workflow is really like, when you think about emailing someone, you want to send the thing in a message and request that they look at it versus just saying, let me go to the field and tag you and hopefully you find it and log in and see the right field. So it really should be more message driven. And that message driven infrastructure is what we call card flow, right? Card space is more static. You're making changes in a template, in a spatial layout. And then once you're doing work, you want to be able to extract or lift that card from that space into a conveyor belt, and then you want to communicate with multiple parties in that conveyor belt. So that's the thing that I think was sorely needed as we was doing that, but it was something that we've been thinking about doing on the same Cardstack Hub infrastructure, but with a different user experience paradigm. So I'm quite proud to show you some of the work we've been working on in the last 2 months or so on figuring out exactly what the UI would be, and this relates to the 4 I just designed system, but it's flushed out much more. So the key with card flow is that it's really about who you're talking to. You're negotiating something, you're filling out a survey or asking something to approve something, then you get a queue of information. So this is the idea. So this is all the things that you need to respond to and you're viewing and recently. And once you open one of this information, you have something like a Slack-like experience. But instead of just a chat, you can actually create actions, you can edit, you can propose, you can invalidate. And obviously different ecosystems have different workflows and different actions and different cards, whether it's event planning or proposing change to the music catalog, who is involved, what versions. This could be a version of a song, and if you update a version of a song, say this is an old version, you can jump around that. But we see this card flow idea to be a very generalizable concept, much like Slack is very generalized to all kinds of communication between teams. But this is a little bit different. It's not just conversation, it's conversational workflow, so we keep milestones, we understand what's going on. I'll give a talk about the concept between card flow and show you more of the screens here. But the idea here is this multi-party conversational workflow experience is really what's necessary to coordinate between different parties, especially in a way where you want to converge towards the truth, where the truth is not just what I type or what I submit to the blockchain, but something that when enough people accept it, that particular piece of information almost get merged into the truth database of this registry, and that becomes reference record that when you scan your phone and Shazam it shows up. But the process of deciding, call it governance, call it business processes, or call it consensus making of a human-machine collaboration, is really what I think Cardstack is uniquely able to support with this encapsulation of these music objects, media objects, and money objects, invoice objects, and more will be discussed about Cardflow as a generic thing. But this is something that was really, really crucial for the next phase of the work that we're doing in the music registry. So it's exciting to give you guys a preview of what that looks like. So, as I mentioned, the UX is something that we're doing design, we're beginning development, using this Card SDK as a basic building block, and then it will be a standard package that's part of the open source code base of Cardstack. The ideal machine learning and AI is, whenever you mention blockchain and AI, people roll their eyes at it, But the truth is that if you have a feed of things coming in, hey, do you want to approve this? Do you want to approve this license? Do you want to sell this to me? Or do you want to trade this with me? You can either look at the workflow and read the email message and say yes and no and make the runtime decision, or you can train a bot to respond on your behalf. Every single time you see this, please do that. And that's really, I believe, how machine learning can plug into blockchain. Not necessarily at the smart contract level, having a smart contract decide whether something is yay or nay. That seems a little scary, a little Skynet-ish. But if people running a node, running a client, running a UI can say, no, I'm not going to be logging in every day, saying yes to 95,000 things. Most of the time, please just make the decisions of whether to approve this metadata request in the music industry, or whether to approve this revisions if you're doing something like in the content management system. Only if there's real controversy or something, I'm not sure if this is something that I should say yes or no, that does the machine say, hey, notify you to come in and review this and more things. So this is likely going to tap into a lot of the Python ecosystem, something that is not just written in JavaScript, because most machine learning is done in Python. We're working on a project to kind of wrap this Python stuff in a Docker container and be able to use it in a plugged-in way, so that you can say, oh, I have this strategy to determine whether I'm going to look at my portfolio, let's say using some future version of Cardfolio to do some automated, either decentralized finance or even interaction against centralized exchange using Cardstack as kind of automation IFTTT layer. That is great and in concept, but you don't want one service doing proprietary software and say, this is the strategy you can run. We want to create something where your data is replicated in your node, whether that's hosted by you or hosted by someone you choose, and then you can plug in through a strategy card what machine learning you want to do. So this is actually pretty important for dotBC in the industry-specific way, so that music company can really use the latest generation of machine learning algorithm to determine whether a song is accurate or whether a request or amendment from a particular party is trustworthy. And there's ways to know that, because there's a lot of data about people and where they come from and who affiliation is, and using that kind of graph analysis in a PageRank kind of way to determine whether that's workable. So there's a partner called RAI, Chris Mercury from Exactors. He's been working with us to figure out what is the plugin footprint for the music industry, but hopefully that becomes the general plugin strategy we can provide to other industry, not just the music and media industry, to plug machine learning algorithm that operates at the edge of the network into making decisions. So organizationally, if you zoom out and look at the whole network working, it seems like the blockchain is smart, but it actually is not the blockchain smart. It's that everybody's using the shared information enabled through the synchronization loop in the blockchain to make independent decision, much like game player playing their own game, and then the overall game board look really smart. But it's this small level edge decision is accumulating this kind of collective intelligence. Very exciting to do that, and it is something that's driven by real business use case, so that a poor person from a label doesn't have to say yes every single time someone's trying to change a misspelling, fix or add a bassist to a particular song. So those things can be automated, and risky things such as taking rights from someone or transferring rights that changes royalty payment at the end of the year. Those requires either more automation, or in some cases, if it is corroborated by other facts, automatically approved by the AI as well. And then the idea of, and this is true for the ION project from Microsoft and the Decentralized Identity Foundation, is that you can always anchor these kind of layer 2 side trees, let's use the term, into different things. So we're looking at the trade-off of anchoring on a permission ledger versus a public blockchain or some, and we're already working on the IPFS and Ethereum for Gitchain generically as a way to store anything that can be stored on Git. Some of that can be re-implemented in other registry infrastructure. Our goal is to not have people who choose Cardstack as the database or this kind of data orchestration layer to have to choose the blockchain underneath it. A lot of these blockchain solutions say, hey, use my blockchain, use my infrastructure before you can do anything on it. Cardstack is saying we're the center. We try to make the whole thing work because we need to understand that the full stack solution has to be demonstrated before people believe that you have that orchestration engine. But we really want to support different approaches because different type of registry, different type of use cases, just as diverse, different type of opinions about what's true, what's not true, and what's important, what kind of speed concerns. But I do believe the public chain as an anchor, especially since you take so much of that work of querying and searching and push it into whether it's layer 2 and IPFS and layer 3 into the Cardstack land, you can now choose whichever blockchain you find more trustworthy. So it's great to see that people are anchoring on Bitcoin. I started my career in blockchain working on Bitcoin-based anchor media art thing, like digital art trading before ERC 721 and CryptoKitties sort of thing. We were doing that on the Bitcoin blockchain, and Hassan was the lead developer, was the main architect of that kind of op return-based infrastructure. So we really believe that different blockchains have different characteristics, and as long as the cost is reasonable, so using this idea of layer 2, you only put one transaction on the Bitcoin or Ethereum blockchain per 5,000 or even 500,000 transaction off-chain in this kind of side tree, whether it's backed by Git or the array structure that Ian has put together, then it's much easier to say I'm paying 1/5,000th of the cost of that Bitcoin transaction or the Ethereum transaction. It's not too bad. So this idea of this trade-off is becoming less and less once we have this layer 2 solution. So it's great to be able to have that type of innovation kind of in lockstep from different people in the industry working towards the same thing. So that's my big update for the day. Hopefully this was helpful, telling you kind of one of the major projects we worked on that really helped us understand what this kind of scalable end user facing application is. It's tricky to do it right, and many people in the industry, almost everybody that was at the W3C workshop is working really hard solving these problems. But we're going to get somewhere with this. This is getting closer and closer. The gap between Web 3.0 and where we see the web's going, and the cloud infrastructure and technology and the scalability of Web 2.0 providing these databases, and it's now converging so that we can actually have something that is ready for end users, allow them to do what they want to do on the network of their choice, and still have something look as friendly and sexy as anything that they've actually done on the decentralized version of the web. So for us here in Cardstack, thank you very much for your attention, and we'll talk to you soon.